Hi guys, this video is on average rate of change. So we're going to go ahead and start by looking at some different functions in some different forms. Average rate of change is basically the slope. So on a straight line, it is the slope. On a function that is not linear, it's going to be the slope of the straight line that occurs between 2 points. But let's go ahead and just do some examples. So these three different functions are all linear, but they're represented in different ways. So this first one is in a graph, then we have a table, and then we have an equation. So to find the slope of a straight line, we just need to find the slope of that line. Okay, so there's a couple of ways to do that. We can use the graph itself, and we can do rise over run, which means how many spaces do I need to go up and then over to hit another point that's on a grid mark. The other way is to do the change in y divided by the change in x. And throughout this video I'm going to be using some notation that looks like this. If I put triangle y over triangle x, that just means change in y over change in x. Basically it's the shorthand way of writing this over here. And then on this last one is an equation, and remember that a linear equation in the slope-intercept form looks like y equals mx plus b. So I know if it's in this form that the slope is just the m in front of x, so the number in front of x. So let's start with the graph. We're going to do rise over run here. I could use the 2 points that are already marked. I could use any 2 points that are on a grid line. So since this one's closer, I'm just going to go ahead and use it. So I would have to go up 2 to get to the same level as that other point. So that's the rise. The run, I would have to go back 1. And because I went back 1, I'm going to say the run is -1. So the average rate of change on this line is -2. On my table, I can tell it's linear because as the x's change by 1 each time, the y's change by +2 each time. So I can see that the change in y is 2 because between any 2 points the difference is 2, and then the x is just changing by 1 every time. So the average rate of change, or the slope, is 2 on this one. Now notice here, if it's linear, it doesn't really matter which 2 points I decide to take the difference. I could take this one and this one, for example. If I do 10 minus 4, that's the difference, or the change in y, over the change in x, which would be 4 minus 1, notice that that is still equal to 2. And that's true of all linear functions. It doesn't matter where you check the slope, right? It's always going to be the same. The slope is not going to change on a straight line. And then lastly, the equation, because this is already in slope-intercept form, I can see that the slope, or the rate of change, is -6. So let's go ahead and take a look at the other one. This here is a quadratic, so we're no longer dealing with linear. So to find the rate of change here, we're going to basically do the same thing. The only difference here is that depending on which 2 points you're checking between, your slope or your rate of change will be different. So if I were checking the rate of change between these 2 points, the straight line that goes between them would be the rate of change between those 2 values, or on that interval. Okay. If I chose to do this lower point and this higher point 0.5 up here, that's going to change the slope, right? It's going to have a different rate of change if I decide to do a different interval. So different intervals will have different rate of changes on the same function if it's not linear. This is asking me to find the rate of change on the interval between -3 and -1. And remember, this is x values, right? So from x equals -3 to x equals -1, which on my graph, let me hurry and just erase all my mess here. So we're asked to find the value between -3. So this point right here was at -3, and this one is at -1. So obviously my graph is not super. So we would have had -1, -2, -3. And then this point here is at -4. But the point here is that we want to check the rate of change between x equals -3 and x equals -1. So we're just looking for the straight line, or the slope of the line between those 2 points. So here, we're not really going to estimate this, but we're going to find the rate of change. And again, that's the change in y divided by the change in x. So the change in y here would be -4 minus 0. And again, I can use the equation or I can use the graph. The change in x would be -3 minus -1. So this is going to give me -4. This becomes a plus, which becomes -3 plus 1, so -2. So -4 divided by -2 is 2. So our rate of change is 2. I also could do that, but just by counting, to go from here up to where the other point is, I would need to go up 4, and then to the right 2. So 4 over 2 if I'm using my rise over run. So either way, we get 2 as the slope. In this table, it's again asking you to find the average rate of change. It's asking on a certain interval. And remember, if your equation's not linear, different intervals will have different rates of change. So we do need to make sure that we're paying attention to which interval it wants us to look on. So this is from x equals 2 to x equals 3. So those are the 2 points that we're looking for. So that would just be this point where x equals 2 to this point where x equals 3. So these would be the 2 values that I would want to check and use the equation on. So I'm going to do change in y, so 9 minus 4 on the top. On the bottom, change in x, so 3 minus 2. Now on this, it doesn't matter which one I put first. Like I could have actually done 4 minus 9 and then 2 minus 3. I would get the same answer. Just make sure you're consistent each time. So because I chose to do 9 first and then subtract 4, because I chose to do this point first when I subtract it, I got to do that one first when I subtract the x values. So this gives me 5 over 1. So the rate of change here is 5. Now notice if I were to do a different interval here, I'm going to get a different rate of change because it's not linear, right? I'm not just adding the same number to all my y values. So let's say we wanted to check between this point here. So we wanted it on the interval from 1 to 5. So I would be using this point here and this point here. My interval would look like this then, right? From x equals 1 to x equals 5. So that would be, the change in y would be 25 minus 1. The change in x would be 5 minus 1, which would give me 24 over 4. So the rate of change there would be 6. So depending on which interval you're looking at on something that's not linear, you're going to have different rates of change. Lastly, we have an equation. So we have y equals negative x minus 1 squared plus 5. Our interval goes from x equals 0 to x equals 2. So remember, these are both x values, so x equals 0 to x equals 2. So these are the 2 points that I want to use. But I don't have the y values yet. I have the x values of 0 and 2. I need to find the y values that go with them. So in order to do that, I'm going to plug the x values in to see which x value goes with it. So if I put 0 in here, I'll have negative 0 minus 1 squared plus 5. Do inside the parentheses first. That will give me negative 1. So negative 1 squared plus 5. Negative 1 times negative 1 is positive 1, but then I also have this negative in front, so that's going to end up as a negative 1 plus 5, which equals 4. So when x is 0, y is 4. Now we'll check when x is 2, so we're plugging 2 in here. So negative 2 minus 1 squared plus 5. 2 minus 1 is just 1. 1 squared is 1, so this is again negative 1 plus 5, so it's also 4. So the rate of change would be the change in y, which in this case is 0, and the change in x, which would be 2 minus 0. So 0 over 2 means there is 0 rate of change there. So think about the shape of a quadratic, right? This one went right 1, up 5, and got flipped. So it's something like this. So what that's telling me is that when x equals 0, it's crossing at 4, right? So there's that point. When x equals, let's see, when x equals 2, so this must be about 2 right here, again, y is equal to 4, because the two sides of our parabola are symmetrical. So because they're both at the same y value, the slope would be 0, right? There's no change if I go from here to here. Same on this. If I went from this point to this point, there's not going to be an increase or a decrease. Okay. So here we have some equations of functions, and we want to find the average rate of change. So again, this is telling me we want to go between x equals 1 to x equals 4. So we're going to, again, plug in our x values to find the y's that go with them, so we know how to find change in y over change in x. So my x values are 1 and 4, and I need to find the y values that go with them. So I'm going to first plug in 1. So f of 1 equals 2 times 1 squared minus 6. 1 squared is just 1, so this would just be 2 times 1, which is 2. Minus 6, so negative 4. So when x is 1, y is negative 4. And now we'll do the same thing for x equals 4. We're plugging it into the function. And that's going to give me 2 times 4 squared minus 6. 4 squared is 16. And 16 times 2 is 32. So 32 minus 6 would give me 26, I believe. Yes. So there's my 2 points now that I can find change in y over change in x, right? So change in y would be 26 minus negative 4. Change in x would be 4 minus 1. So that's going to become a plus, so I've got 30 over 3. So my rate of change there is 10. Okay. So let's do a couple more here. So again, these are my x values in the interval, right? It's telling me to look between x equals negative 3 and x equals negative 2. So those are going to be the endpoints that I'm looking between on the graph. So when I plug negative 3 in here, I'm going to get negative 3 times negative 3 is 9. So this would be a negative 9 minus 3, which is negative 12. So I've got negative 3, negative 12 as one of my points. And then when I plug negative 2 in, that's going to give me 4, which is negative. Negative 4 minus 3, so negative 7. And then just do change in y over change in x. So it doesn't matter which one I do first as long as I'm consistent. So if I do negative 12 minus 7 minus negative 7, then because I chose to do this one first, I've got to do this one first on the x. So negative 3 minus negative 2. Remember, if you have a double negative, it's going to become positive. So negative 12 plus 7 is negative 5, and then negative 3 plus 2 is negative 1. Negative 5 divided by negative 1 is 5. So there's my rate of change. Okay. So last one, from x equals 6 to x equals 8, so those are my x values. I'm going to plug those into the function to find y. So square root of 6 minus 5 equals the square root of 1, and the square root of 1 is just 1. If I put 8 in here, I'm going to get square root of 8 minus 5, which is the square root of 3. Square root of 3 is not going to be a whole number, but we'll just go ahead and use the estimate for square root of 3. So that would, if I round it off to the hundredth, it would be 1.73. And then we just do change in y over change in x. So 1.73 minus 1 over 8 minus 6 is equal to 0.73 over 2. And if I put that in my calculator, I'm going to get an error. I did something wrong. I put a double divide sign. So 0.365. So that's the rate of change there. Okay. So let's go ahead and look at independent versus dependent variable. So an independent variable is the one that has more freedom. The dependent variable is the one that has some dependence on the other one. So x is going to be the independent variable. So if we look at our graph, x is going to be the independent variable, y will be the dependent. So that's because x is your input. So as you put x values in, that's going to determine what the y values are. So the y values depend on the x values. So you're going to need to know that just for a little part of your assignment. So if your independent variable is increasing, that means you're going to the right, right? This one's the independent. If your independent variable is decreasing, it would be going to the left. So this would be increasing, and this would be decreasing. If your dependent variable is increasing, that means it would be going up, right? So this is dependent, If it's increasing, it would be going up. If it's decreasing, it would be going down. Okay, so that might help you with a little bit of your assignment. Okay, now we're just going to do a couple of story problems. So Jenny started a savings account with $400. After 2 weeks, she had $500. So we're going to kind of make an XY chart here, and we're going to decide which data points we have, and then we're going to find the rate of change. So basically, anytime you have time involved in your equation, time is going to be your X value. And then your Y values are going to be whatever the other thing is. It's depending on how much time goes by. So in this one, the money is going to be Y. So at time 0, when she opened the account, she opened it with $400. After 2 weeks had gone by, she had $500. And after 6 weeks had gone by, she has $625. So we can see that this is not linear because the rate of change between the first data point, 0, 400, and the second, 2, 500, would be 500 minus 400 over 2 minus 0, or about $50. Right? So that's the rate of change in the first 2 weeks. But then in the last 4 weeks, we have a rate of change of about, so we have 625 minus 500 over 6 minus 2, of about 125 over 4, which equals, let's see, about $31.25. So depending on which weeks I'm looking at, there is a different rate of change. That's because she put more in initially than she has later. But this is asking us what is the average rate of change for each week. So because of that, we need to go from the beginning of her checking out to the end. So we actually need to find the rate of change between these 2 points. So basically I was just trying to show it's not linear, so depending on which weeks you look at, it's going to change. But let's go ahead and find the overall rate of change. So that would be 625, that's the amount she's ended with after 6 weeks, minus 400, divided by 6 minus 0. So this would be 225 over 6, which is equal to $37.50. So overall, if we're taking the whole time period into consideration, she's contributing on average $37.50 per week. Okay, even though initially she was adding more per week than she was later. Okay, Carl left his home at 2 p.m. and drove 153 miles to his grandma's house. He arrived at 4:30 p.m. What's the average speed of his car on the trip? So again, our time is going to be our X variable, and the miles that he traveled will be Y. Always put time on X, okay? So at time 0, when he left the house, he had gone 0 miles. He drove 153 miles, and it took him, it looks like about from 2 to 4:30, about 2.5 hours, so that'd be 2.5 here. And so the change in Y over the change in X would just be 152 minus 0 over 2.5 minus 0, or 152 divided by 2.5. So it looks like he went approximately 60.8 miles per hour. Okay, so on average, that was his speed. It doesn't mean he went that speed the entire way, right? But on average, he was going about 60 miles per hour. Okay, so lastly, we're going to look at a chart. If I am asked to find the average rate of change on the table, I see that the equation is here, f of x equals 5x minus 7, but it's actually giving me all these data points. When x equals -1, y equals -12, when x equals 0, y equals -7, and so forth. This first section here is asking me to find the rate of change between -1 and 2. So again, these are both x values, right? So that's telling me that I need to look at this data point because x equals -1 here. And then when x equals 2, that's this data point. So these are the 2 points I'm using in my calculation. So change in y, I could either do 3 minus -12 or -12 minus 3. as long as I'm consistent in the order, if I choose to do 3 minus negative 12, because I used the y value from this point first, on the bottom I've also got to use the x value first from that data point. So 2 minus negative 1, so those both become plus, so that's 15 over 3, so the rate of change would be 5. Okay. The second interval wants me to look between, I'm going to put a square instead of a circle on this one, or a rectangle, I guess. So 0 to 1, so it would be this point and this one. So my change in y would be negative 7 minus negative 2 over 0 minus 1. So that becomes negative 5 over negative 1. So again, the rate of change is 5, right? So this is a linear function because every time here 5 is just getting added on. So I could calculate this one too, but since it's linear, I know it's also going to be 5. But let's go ahead and do it. So if I'm using this point right here, because that's where x equals negative 1, right? And then to 4, so this one here. So the 2 with the star by it. So 13 minus negative 12 over 4 minus negative 1. So these both become plus. That would be 25 over 5, which again is equal to 5. So when your function is linear, the rate of change won't change depending on your interval. If it's any other shape, then you are going to see some changes depending on which interval you're looking at. Okay? So have a great day, and if you have any questions, please email me, and we'll see you next time.